access through indexing. If a data type is ordered, then only we can access with the indexing, or else we cannot. Fine. Getting through this, there is one catch over there. I'll just print the tuple first. It is quite obvious that it returns the value. Yeah, it returns the values in the form of tuple. Okay. Now, I just now you may say that how to declare only one value in a tuple. So this makes some sense, right? See, tuple. So to declare only one value in the tuple, you need to write the object value with a comma. The comma is really important here. See, if I write like this, what I am doing is like I'm assigning the value of 2 to this memory location called tuple, which is an integer. So basically using a parenthesis doesn't exactly make sense that it is a tuple. Rather than now it takes the value of 2. Now you have seen this output, right? The output is in the form of also tuple. Now I'll run this program. Now see, it just prints 2. Did you catch that? Because we did not use any comma. So it directly takes the value of 2 as an integer rather than taking it as a tuple. So it is not a tuple. I can also prove it with the by printing its type. There is also a function called type, which we have discussed in the first episode. So print of type. So type gives the data type of that type of tuple. So it gives the tuple. Fine. So class int, it is not taken as tuple, rather it is taken as integer. So whenever you're declaring a single element in tuple, make sure that you declare with a comma. That is what you can get class tuple. Fine. If I print right now, print tuple, tup. Fine. Now I'll get a tuple. See, tuple. Be careful over this. And to declare an empty tuple, yeah, it is as quite easy as that. Like just parenthesis makes the work done. But yeah, declaring only one element makes some difference here. And yeah, more than one element is same as list. That's it. And once tuple is defined, the elements cannot be altered or manipulated. We have discussed that thing. And consider the following tuple. We have this tuple, and the count function and index function we have already discussed in this list things. So it is same as that. So you can get and try over that. Now getting onto the another data type called sets and dictionary. So sets and dictionaries is also a data type in Python. So first we'll just discuss what exactly dictionary is. So dictionary is called as key value pair. Dictionary is a collection of key value pair, because dictionary consists of two things. One is key and another one is value. Okay. And the properties of Python dictionaries is, first, the dictionary is unordered. Right? You may question that, okay, the dictionary is unordered, right? So the values are jumbled in, by this word, it means that the values are jumbled. So probably you said that you cannot access if a data type is unordered, right? But yeah, in dictionary, it is not like that. It is unordered. Yes, it is true that it is unordered, but you can access that with indexes called keys. Fine. Be clear with that, because it may be a confusion moment for this, because any data type which is not ordered cannot be accessed through indices, right? Because the internal memory structure of any like this structure tuples sets dictionaries will be like this. So these are ordered like 0, 1, 2, 3, 4, 5, 6, 7, 8. So these are the memory locations. So if it is ordered, you can just call this memory location through indexing. So these are called indexes, right? So from this, you can just call the index and you can access the belonging index value. Fine. If the data type is itself an unordered data type, so these indexes are not even present. So the values are assigned randomly. So you cannot even access the thing with an index sense. That makes no sense. But in dictionaries, there is one exception that you can access with the keys, not with the indexes, but with the keys. Fine. And dictionary as a list, dictionary is also a mutable data type. Fine. And it is indexed only with keys. That is what I have mentioned over here. And cannot contains, yeah, this is the main thing. It cannot contains the duplicate keys, but yeah, it can contains the duplicate values. So these are the keys. So we just define dictionary like this: key, value. So this is the key and this is the value. There may be n number of values. Duplicate values are accepted in Python, but duplicate keys are not at all accepted. Be clear with that. Now we'll just try to define a dictionary and just access all these dictionary methods over there. So dict.py, fine. dict is equals to, and here now I'm creating a key and value. Here here the key and value may be any data type, any user defined data type. It may be int, float, tuple, dictionary, set, anything. Fine. The value may be anything, but the key is restricted to int, float, and string. Fine. Now I'm creating CSI. Fine. And bootcamp. So CSI is a key and bootcamp is a value. Fine. And each element is separated by comma. 23. And now I can access a string. Fine. And pretty, I can also assign float values to this 90.09 to the another integer or value or string value. Any user defined data type is acceptable in dictionaries. Fine. Now, if I want to access the value through the indices, then print of dict of, now I need to access with indices. Indices in the dictionary always refers to the keys. Fine, it is unordered, but you can access. So I'll access through CSI. It is also case sensitive, so be careful with that. Fine, now I'll just print, it must print bootcamp. Fine, so it has printed bootcamp. So I've accessed the CSI, the value of CSI through indexing. Fine, clear. Now we'll just discuss all these dictionary methods. So the first method is a.items. So items just returns a list of key value tuples. Let me explain over here. I'll comment this print, and so dict.items. Fine. So this items, so this is key and this is value. Both the key and value are together called as items. That's it. If I print this, you can see the output. Fine. Yeah. Dict items, CSI bootcamp, 23 Rohit, 90.9, 56. So we have accessed all the items with this method called dict.items. Now I'll try to now I'll just move on to the next method called dict.keys. So keys is nothing. So these are keys, right? CSI 23 and 90. If I want to access only the key value, then I can use the function called dict.keys. Keys, keys, yeah. So see, you can see all the keys 23, CSI 23 and 90.0. You have just access all the keys. In the same way, you can just access all the what is that values also. Print of dict.values. Fine. So it just prints bootcamp, Rohit, and 56. See, bootcamp, Rohit, and 56. They are pretty fine. And we have discussed that dictionary is a mutable data type. So if it is a mutable thing, we have to, there must be an option called update, right? So that is what we are performing just over here. So if you want to update any value in the dict, it is pretty easy, like dict.update. Fine, inside update, be careful that I need to again pass a dictionary. Fine, again I need to pass a dictionary. This is the careful thing that you need to be. And what I am doing is like, okay, ready, I'll pass another value called Vishnu, and it has a thing called 99. Fine. So after this, I just print the dict. Fine. And yeah, you can see that CSI bootcamp 23 Rohit 90.09 56. These are the values which are there in our previous earlier dictionary. What the value is added is Vishnu 99. So this is the dict.update. Updates the value in the last. And after this, we can there is another method called get. I'll get back to the get method in a moment or so. And moving on to the pop and clear methods. So pop is a method. Uh, So pop is a method where it is used to remove the element from the dictionary, same as in a list. Fine. So dict dot pop. Okay. Now inside pop, if you carefully observe with this list thing, inside pop, what it has taken is index value, right? Pop always takes index value. We have discussed in list also right now only. So it takes the index value. Now you can question that what is the index value in dictionary? As I mentioned, the index value of the dictionary is key. So it takes the key. And the key I am entering is CSI. Right? Now I'll print the dictionary as it is. See, CSI and along with that value is just popped. If you enter the key along with the key, the value is also will be popped. Fine. 23 Rohit 90.0956 are printed as it is. That is that much. And clear. So clear is a function where it just clears all the elements of the dictionary. So dict dot clear. And it returns the empty dictionary. That's it. See, this is the empty dictionary. Right. And yeah, now I have told that get method, right? Fine. Now I'll get back to the get method. So I'll just copy this over here, and I use get method. Get. Well, now first let me demonstrate what get method does over here. Dict dot get. Okay. Now what I'm doing is like taking CSI. Fine. Now the get method is uncommented, so it is only working. So what it is doing is what it is doing is getting the value, like getting the value of that key which you have passed, which is CSI. You have passed CSI, right? So it is getting the thing called bootcamp. Pretty good. Now you may question that this is also done in this, right? By indexing also we have done the same thing. So why is there another method called get? Now let me come to that point. Now I'm uncommented this and I'm running this thing, which is accessed through indexing. So it also prints bootcamp. It's fine. Yeah, dict. Okay. Yeah, it also print bootcamp. So both the things are doing the same thing. Then why is there a difference in get method? Yeah, I'll come back to it. Okay. Now inside dictionary we are entering a key which we know that it is there, it is exactly there in the dictionary. What if there is certain instance where the user don't know whether the key is there in the dictionary or not? Okay, now I will enter some garbage value. Fine. Now I'll try to print this. Fine. We are accessing through indexes. It will obviously throw an error, right? It throws an error. Now, now I will do the same thing inside the get method. I'll enter a garbage value again. Fine. Now I will run this. It won't throw any error. It just throws none. That's it. It is a major game changer in this, because if you run a big programs, then you cannot exactly know where the error is going. So that is what the difference between accessing through indexes and get. Fine. If the element is there, if the element is, you know that if the element is there in the list exactly, then you can use indexing, or not use always get function. So with that said, we have completed all the methods of dictionary also. Nextly, we are moving on to the set. So what exactly is set? So set is a collection of non-repetitive elements. Fine. Set is a collection of non-repetitive elements. First, we'll know the behavior of set. Behavior of set is mutable. So set is mutable. Fine. So you can change the values, you can add the values, you can delete the values. That's pretty allowed here. So set is a collection of non-repetitive elements. First, we'll just access all the properties of the set. So the properties of sets are unordered, unindexed, cannot contain duplicate values. If there are any duplicate values, it merges the duplicate values and takes the only one value, not any duplicate value. And these are unordered. These are straightforwardly unordered, and you cannot even access through indexes. Fine, be clear with that. Now we are just going on to the sets.py. So .py is the extension which we need to use to create a Python file. Enough, I just create a set. I'll just create set called 23, 46, 36, and 23. Fine. Okay, now I have taken, see the set carefully. I have taken 23 two times. According to our definition, set must, it will not accept the duplicate value. So now I try to print the set. Yeah. As you can see, okay, set definition is by this. Yeah, fine. Yeah. By this, we can see that 23, 45, 78, 36, and 23, whereas the output is 36, 45, 78, and 23. The first 23 is not printed. And also, you could see that the order is jumbled over here, right? The first is like 23. Okay, if it removed the 23 also, 45, 78, 36, 23 must be the exact order, but the order is quite jumbled. So that is what it is, unordered, and you cannot access through indices. And it also takes only what is that does not take any duplicate values. Now there are many lot functions that are used on set, many mathematical functions like intersection, union, symmetric difference also depend on this set. We'll just discuss all those things in a while. First thing is like length. So length is the function which is common to every method, every data type, I would say, because length is a thing which returns the length of that data type. So now I wanted to print the length. So len of s. So what is the length? 1, 2, 3, 4, 5. 5, right? The length must be 5, right? No, it will print the length as 4. Okay, because the duplicate values are not ignored. Yeah. So I've gone across the length function and dot remove. So remove function, I'll come in this and print of s dot remove. So remove function always take the object value. So now I want to remove the value of 45. Fine. And now I'll print the set. So print of s, obviously 36, 78, 23. That's it. And this method doesn't print anything. Fine. So you can just ignore the print over here and just you can run directly. Fine. If you run that also, that's not a big deal. And after this pop here, here the thing comes. Okay, you told that pop thing doesn't take any, doesn't have any indexes because it is unordered. So how does pop works? Because pop always takes the index value, right? So in the pop function, you doesn't pass any indexes argument s dot pop. It directly works like that. That's it. It pops any random value. That's it. It just pops. If I comment this and run, then you can see 36, 45, 78, 23, right? If I uncomment this and run, it just pop any random value, which we cannot predict. So that is pop. And if I enter any value like index value in the pop, it throws an error, right? Be careful with that because in sets pop doesn't take any parameter. And s dot clear obviously clears all the set. And I'll come in this and run that s dot clear. Yeah, so it shows a null set. Fine. And now we are performing union and intersection of these sets. Let me define another set called S2. So S2 is equals to, let me take the value, let me just alter the values. 1, 2, 3, 4, 5, 6, 7. And 4, 5, 6, 7, 8, 9. Fine. And I take the intersection. First we'll just go to the union and just come back to the intersection. So union of S2. Like this is the S dot union of S2. The two sets are passed like this. Now I'll just print over this. See, I'll just comment this. Yeah, it returns the union of all set. It prints from starts from 1, takes up to 7, and goes here and prints up to 9 and eliminates the duplicate values. It just what it is doing is like just merging the two sets and just keeping into a single set because the set have a default property of eliminating the duplicate values, it does the same thing. Now we'll just get back to the intersection kind of thing. Print of s dot intersection of s2. Fine. Now it gives the common values. It has given pretty common values. Fine. Now here, what we are doing is s dot intersection of s2, right? We are accessing the intersection method from the s, right? Now we are accessing the intersection method from the s2 set. So that doesn't make any sense over there. But yeah, that makes a sense when you use a difference operator. Let me touch that also. Print s dot difference. If I pass s dot difference as s2, and if I pass s2 dot difference of s, see these both are make a different answer. See, 1, 2, 3, and 8, 9. So these are a bit different answers. So be careful with the mentioning of from which method you are calling that. Okay, but that doesn't make any sense with intersection. But if you are using difference, yeah, it makes. If you use symmetric difference, the name itself says it is symmetric difference. So that is not a problem there. You can use S and S2. Hope so you got that. Fine. Moving on to all these methods. Now we're just moving on to the conditional expressions. So what exactly are conditional expressions? So conditional expressions are nothing but if one condition satisfies, if one thing met a single condition, if that becomes true, then the block inside that gets executed. That is that simple. If not, it just comes out of the block. It doesn't execute that piece of code. It just comes. If it finds any else block with that, it just executes that, or else it just the control just goes out of the thing. That's it. So we just see how a basic if else condition are written over there. So if else, okay. Now what we are going to do is we are just taking the age of the user, and we are telling that he whether he is eligible to able to drive or not. That's it. Now I'm taking the value of a as from the user. So int of input of enter your age. Fine. Now I'll create a basic if condition. So if a is equals to, we have discussed this, the difference between is equals to and a single equal to in the first thing. The is equals to is also called as equality check. So it checks equality rather than assigning the thing. So after this, if the user is greater than or equal to, the user's age is greater than or equal to, then he is able to or eligible to drive. Right now, I'll just print this print of eligible. Fine. If not, okay, first we'll execute this and just come over there. Now it just ask the value. Now I'll enter the thing called 56. Fine. It is just printing the thing called eligible. So so it is obviously 56 is greater than 18. So it is printing the thing. Now what if I just write let it come. Yeah. Now what if I write 12? Now you can expect no output. See, there is no output for 12. So to overcome this situation, we use a block called else block. So else block is nothing but if the code inside, if this condition becomes false, then this code will obviously will not be executed. Then the control will be jumped out of this if block completely. If you want to controverse the if condition, then instead of writing another condition, you can directly use else condition and make the work done. So I'll just printing not eligible. Fine. If I enter my 56, it obviously prints eligible. Now, if I enter 12, it is also printing not eligible. So if the condition is converse, the else block is used. Fine. Now we are using some relational operators and logical operators with this, which is already discussed. And now we'll just go to else if or elif clause. It is also called as elif ladder. Fine. Now what I do is, if I want to restrict the age up to 100, so I can use else if. In Python it is elif. Fine. Elif a is less than or equal to 100, print eligible. In this piece of code, if a is greater than 18 and if it is less than 18, it just prints the same thing, eligible. But if it goes beyond that, it just prints nothing. So if else if clause, first if the condition of, it sees that if the condition is met or not. If it doesn't work, it just goes to this block. Fine. If the condition here also doesn't work, it just executes this. Among this, if any of the condition just gets executed, then this else block will never get executed. Fine. And after this, we need to go to the loops. And so loops are nothing but if you want to iterate a piece of code n number of times, we just use a thing called loops. So we are iterating the things. So that is what we just use loops. And there are two types of loops in Python. So the first one is while loop and the second one is for loop. So we'll just see the basic differences between the for and while loop. Okay. And now what I do is like print 1 to 10 numbers. If I want to manually print 1 to 10 numbers, then what should I do? Print 1, print 2. I, I need to write these print statements until 10. Okay, it is fine. But if I want to print 1 to 100 numbers, I cannot write this piece of code. That doesn't make any sense, right? So to avoid this, there is loops. So if you want to iterate over anything multiple times, you can use loops. So the same thing I can perform that for I in range. As we have discussed, in is a thing which is called as membership operator. So we'll just discuss what range function is. And now I'm entering the values called from 0 to 11. Fine. Be careful that I entered 11. I need the values up to 10, but I entered the 11 because this the second parameter is exclusive. It doesn't take 11, but it takes 11 minus 1, 10. Fine. Now I'll print I. Print of I. Fine. Yeah, it just printed from 1 to 10. But I have entered up to 11. Be careful with that because this is exclusive. Fine. So the range function in Python is used to generate a sequence of numbers. And if you want to generate a sequence of numbers, you can directly use range function and generate all the things. Okay. Now if I do the same task, which is a basic task with using while loop, while I'll take j here. J is less than equal to 10. 10. Fine. Print j. Before that, one thing you need to be careful that in I, we did not declare the I variable anywhere. But in while loop, you need to obviously declare a variable with some initial value. Then only it works. Fine. Now we'll just run this code. Okay. I need to increment the value in here. Here is the biggest mistake that we need to just increment the value by a required thing in the while loop. So yeah, you can see that it has just printed from 1 to 10. So The main thing is like in for loop, what it is doing is the range function is automatically generating the value. But whereas in while loop, it doesn't automatically generate, it just checks this condition. If this condition becomes true, it starts executing this. If it doesn't, in while loop, it never increments the value. Be careful of that. If I just remove this and try to execute that, the loop just goes on infinite loop because j is 0, and if j value 0 is obviously less than 10, so it prints j and comes back again to the j, like while loop, and it the value of j is not at all updated, right? So the value of j is still 0, so it again iterates over the loop infinite number of times, so it is always printing 0 here. Fine. So whenever you write while loop, you need to increment this value. So these are the basic examples of for loop and while loop. Now we'll discuss a peculiar condition where mostly it is not used, but yeah, for with else condition. Now you may have a doubt that we can use if with an else. It is pretty fine, but here we are using for with an else condition. Let we just see this. Now what I did here is, now I'm generating the values from here, and I use a if statement. If I is equals to 6, fine. I'm using a function called break. Okay, first, before letting on to you on this, I need to just discuss what is break and continue, right? So I'll just discuss what is break here. So break is a thing which if the break is encountered by the Python interpreter, the control is pushed out of the loop and the loop will die over there. That is the main function of break. Fine. Now let us see what it happens. See, first in for I in range, I starts with 0. Fine. It just goes and checks this condition. If is 0 is equals to 6, not right. So this condition will not be executed and it just prints 0. In the same way, the I value will be increased by 1 and just checked by this condition 1. So no, 2, 3, 4, 5. If 6, whenever the I value becomes 6, it just enters into this if loop. What is that? If condition. And inside the if condition, the block of code is break. So it just breaks the loop. Fine. It just breaks the loop and comes out of the loop. That's it. So after 5, you cannot see any output. See, so if I print anything here, done, it prints done also because it is out of the loop. The loop ends up to here. Out of the loop, whatever it is there, it just prints fine. So this is the main usage of break. Break is used to break is used whenever the user wants to get out of the loop. That's it. And so what is the uh, difference between break and continue? Now I'll execute the continue, then you'll get an idea. See, in continue, it just goes 1, 2, 3, 4, 5 is common. In break also it is common, right? But whenever it encounters 6, it encounters a condition called continue, right? So what does continue do is like only for this iteration, it just comes out of this and starts the next iteration. Be careful with that. It doesn't come over the loop like break, whereas it just comes out of only the single iteration, increases one iteration and stays in the same loop. Fine. If you see this output, there is 1, 2, 3, 4, 5, and there is no 6 because if 6 is encountered by the if loop, the print statement will be ignored. Continue statement, if the continue statement is executed, the code below all the continue statement will never get executed. Fine. For that iteration, the code below the continue statement will never get executed. After that, in the next iteration, it starts executing. That is why we did not got the 6. Fine. This is the major difference between break and continue statement. Now we need to see what is for else loop, right? In else condition, I am writing print of hello. Fine. So now I'll use break. Now I'll try to run this. So obviously have the break, you will get a 0 to 5. The else block here is not executed. Be clear that the else block here is not executed because the loop is not terminated naturally. Inside, if for else is used, the else block will only be executed when the loop is terminated naturally. But we are breaking the loop by manually, like by getting the user thing, we are breaking the loop. That is why the else will not get executed. If I just remove this block and I execute, you will get all the output with the hello, right? If the loop gets executed and terminates naturally by itself, then the else statement will be, else block will be executed. Be careful with that. If the loop is terminated manually by the user, then else block will never get executed. And there is another thing called pass statement. So we'll just use pass statement here also. Fine. Now, if I inside the loop, if I declare an if block, okay, I am just using a condition called I is equals to 7. Okay, and assume that we are writing a very high level program, and the user is in a dilemma that whether he need to implement the if code in certain way, or he need to make it into a class and give to the another user. He's in a big dilemma, so he wants to just ignore the if, but he needs the condition of if. Then the pass statement is used, and if I print I, yeah, it obviously prints from 0 to 10. That is not a big deal. Now you can question that what if there is no pass statement? The compiler will throw an error. Okay, because if block without any code doesn't make sense to the compiler. That is why you need to use pass. If the user has encountered this code in a future stages, then he can remove the pass and write whatever the code he needs there. That is the main use of pass over there. And yes, just do you have any doubts?
Hello. If anyone is having any doubts, you can ask or put it in the chat box. So I think no one is having any doubts. Uh, Thank you, Vishnu, for such a wonderful session. And I thank all for attending this session. Uh, Rohit Vishnu check the chat
Yeah.
box. There's a question.
Bro, we will teach the advanced topics too in the further sessions. Yeah, we'll plan it soon and just come up with all the advanced topics. And with the OOPS concept also, we'll just be coming with that soon. Still any doubts?
Yeah, I would like to thank everyone for attending this session.
File handling.
Uh, thank,
Yeah,
Thank you. Check the chat section.
yeah, yeah, file handling. So actually, we have planned file handling for today. The next topic is file handling itself. But yeah, we'll cover that file handling in the next episode. So this is what file handling is. We'll cover that file handling in the next topic, next episode. And duplicate keys means, okay. So what is meant by duplicate keys? Uh, just let me come with the duplicate keys. Let me write a short piece of code here. So yeah, this is the dictionary, right? Enough. Uh, this is the dictionary that we have used right now. Now I can, this is the key, right? And this is the value, fine? Now I am creating another key, right? Like Kumar, yeah? This is another key. Now I am assigning the same value called bootcamp for this key. And I'll try to print this dictionary, fine? As you can see that CSI Bootcamp 23, Rohit 90.09, like 56, Kumar and Bootcamp. So this Bootcamp is a duplicate value. So there may be n number of duplicate values inside a dictionary. That is, there is no restriction, but there must not be duplicate keys. Now I have demonstrated the duplicate values. Now I'll demonstrate with the duplicate key. Fine. Now I am changing the value to like Sunday. Fine. And I'm using the key same as CSI. Fine. Now I'm using the same key called CSI. Now what the output I get is the bootcamp value of CSI doesn't be there on the memory, rather than it is overwritten by the Sunday value. As you can see, if I execute, the CSI will be printed by directly Sunday instead of printing the bootcamp. So whenever the interpreter is going checking all the dictionary values, it checks in this way from left or to right order. If it encountered CSI with bootcamp, it stores CSI in the memory location with bootcamp. If it found any duplicate keys, then it rewrites the value of bootcamp to Sunday and prints that value only. So that is why there is a possibly lossy data conversion in duplicate keys. So that is why duplicate keys are not allowed in the dictionaries. Hope so you have understood that. Okay, I'll provide the link here. Yeah, I provided the link for the episode 1 also. Still any doubts? Inheritance. Yeah, we will be covering that in the next episodes. Episode 4, probably we will do that. Object-oriented and inheritance polymorphism, we'll cover that. Still any questions?
I think there are no other questions. Then we'll end this meet here.
Yeah, thank you.